Dear students, today we'll see what do we mean by band stop filter, or it is also called as band elimination filter or band reject filter. So here our topic will be active band stop filter, or it is also called as active band rejection filter, or it is also called as active band stop filter or active band elimination filter. Now, basically, the band stopping will be done by R and C circuits, and the active means it is going to amplify the output with an active device like an op-amp or BGT. So here, if you see the first or definition of basic filter, we know that a filter is a device that passes electrical signals at certain frequencies or frequency ranges while stopping the other frequencies. This is a basic filter. Now, in this filter, we have studied types like low pass filter, high pass filter, band pass filter, and band elimination or band reject or band stop filter. Now, we have also seen that band pass filter we can achieve by connecting a high pass filter and low pass filter in series. Similarly, band stop filter we can achieve by connecting a low pass filter and high pass filter in parallel and then adding their outputs, amplifying them, will get a band stop filter. So to go to see the definition of band stop filter is also known as a notch filter if the band of frequency which you are going to stop is very narrow. It blocks and rejects frequencies that lie between two cutoff frequency points and passes all those frequencies that lie on either side of this range. So if you see the basic construction using low pass filter and high pass filter and a summing amplifier, we can get a band stop filter. So here high pass filter and low pass filter are connected in parallel. So here you are having your low pass filter and this will be having its a cutoff frequency FL. Say this is 0 to FL. Okay, this is low pass filter. And then this is your high pass filter. This will be having a cutoff frequency from FH onwards, and this will be a pass band. This will be a stop band. If you connect them in parallel, these are connected in parallel, and then join their outputs to a summing amplifier. This is summing amplifier. Summing amplifier. Then at the output, you will get a thing like this. First, you will have a low pass filter characteristics, and then you have a high pass filter characteristics. So this is your pass band. This is cutoff frequency of low pass filter. This is cutoff frequency of high pass filter. This is pass band, and this is stop band. So this is a graph of gain, gain versus frequency, and in this you can see that you can stop a particular band of frequency here. So even here we have shown this is a stop band. It's a very narrow. If the stopping band or the band of frequency which is rejected or stopped is very narrow, then it is called as a notch filter. So here if you see the description for that, the bandstop filter is formed by the combination of low pass and high pass filters with a parallel connection. The name itself indicates that it will stop a particular band of frequencies. It is just working as opposite of band pass filter. Since it eliminates frequencies, it is also called as band elimination filter or band reject filter or notch filter if the band of frequency which you are rejecting is very narrow. Then if you see circuit wise, then you can see a low pass filter here. So on top we have shown a low pass filter. So here you can see this R, L, F and this C. will do the low pass filtering. Okay, and then you are having an amplifier here, A1, and this will be the output of low pass filter in amplified version. This is your low pass output. Okay, so here the cut, a cutoff frequency will be FL, which you can write as 1 by 2 pi RC. Okay, and R and C are the R values which you have connected for low pass filtering. Then here you can have a high pass filtering action. This C in series with the input and R in parallel with the input. So here you can have high pass filtering. This is going to amplify the high pass filtering output, and the output of high pass filter will be like this. So you will be having a stop band and you'll be having pass band above a certain frequency. So here the cutoff frequency will be say FH. So this is the cutoff frequency of high pass filter. Above this frequency, all the signals are passed, and below this frequency, all the signals are stopped. If you take these two outputs and give it to a summing amplifier, if you add them, then the output of that will show you. If you take the characteristics, if you take the gain versus frequency characteristics, so initially you will be having a low pass filtering action, and then you will be having a high pass filtering action. So this is low pass means 0 to FL, say, and this is FH. Okay, so you'll be having a pass band here, and this band of frequency from FL to FH will be stopped, attenuated, or rejected. So this is stop band, and again this is pass band. So you are going to stop a certain band of frequencies. You are going to reject a certain range of frequencies. That certain range of frequency can come up to a lower of one frequency also. And when the band is very narrow, you can call the filter as notch filter. NOTCH, notch filter. So if you see the ideal graph of a band stop filter, or it is also called as band elimination filter or band reject filter, you can see that if you see the graph of voltage gain versus frequency, then you can see here initially you have your stop pass band here. Here you are having your pass band, then you are having your stop band, and then you are having again the pass band. Okay, so here the frequency FL, whatever you have, will be the cutoff frequency of low pass filter, and here frequency FH will be the cutoff frequency of high pass filter. So all the frequencies between FL and FH will be rejected or stopped or attenuated. Attenuation will be done more here, and that is why that band of frequency is stopped. Okay, so this is rejected, or it is not allowed, it is stopped. Okay, or it is eliminated. This is eliminated. So based on any term we use, we can call it as a band stop filter, band rejected filter, or band elimination filter, where FL indicates the cutoff frequency of the low pass filter, as I've told you earlier. FH is the cutoff frequency of the high pass filter, and the center frequency you can write as FC is equal to under root FL into FH. Now, if you see a practical bandwidth or a practical frequency response of a band stop filter, so here you can see you are having your first high pass filter. So here you can see first you will be having your low pass filter here. So this is your low pass filtering action. Okay, so this action, if you take the maximum gain and come down to minus 3 decibels, so you will get a point here, and that point, if you mark it on a frequency x-axis, you will get FL. This is the cutoff frequency of the low pass filter. So you can say that the frequencies below FL are passed, and the signals which have frequency above FL are stopped. Okay. Similarly, here you can have a high pass filter graph. Now, this is your maximum gain. If you come down to minus 3 decibels, you will get a point here. This point you can mark it here as FH. Okay, this is the cutoff frequency of high pass filter. And then as we have seen that the center frequency FC will be your under root FL into FH. Now here, the frequencies from FL to FH will be blocked, will be stopped. Frequency will be, or you can say it can be attenuated, okay, or it can be rejected, okay. So that is a band of frequencies you're rejecting, and frequencies below FL will be passed, and frequencies above FH will be passed. So if you see that if you make the band of frequency which you are going to eliminate very narrow, so here you are making it very narrow. This is a narrow band of frequency. Okay, it can come down to a single frequency also. It is a very narrow band of frequency. If you are having a very narrow band of frequency, then that is called as notch. Okay, that is called as notch, and because it is stopping a very narrow band of frequency, it is attenuating a very narrow band of frequency. The band stop filter can be called as a notch filter also. Okay. Now, if you go to see lastly the applications of band stop filter in telephone technology, these filters are used as the telephone line noise reducers. These are widely used in the electric guitar amplifiers. These filters are used to eliminate unwanted harmonics, that is, multiples of the fundamental frequency. These are used to reduce the static on radio, which are commonly used in our daily life. These are also used in optical communication technologies. They are also used in image and signal processing. These filters are highly preferred to reject noise. These are also used in high quality audio applications like public address systems, PA systems. These are also used in medical field applications, that is, in biomedical instruments like ECG for removing line noise. Okay. So, all these things are there, all these applications are there where you can use your band stop filters. Thank you, students.